Please make sure the contents of your kit are complete. Here is a selection of the necessary tools. Now you can start with the antenna assembly. First, take the elevation bolt and attach the plastic nut with 2 spacers. Then, attach the bolt to the elevation head with 2 metal bolts. You may have a later version of this antenna with a metal elevation bolt already attached to the elevation and azimuth head, as shown here. Take the polarization disc and position it with the letter A on the disc, aligned with the A on the elevation head. Insert the 4 coach bolts from the interior and secure using a washer, split washer, and finally a nut. Only tighten these 4 nuts to finger tightness. Attach the 2 arms to the sub-reflector, making sure that the 2 notches on the arms are located as shown. Using a bolt with washer and split washer, secure the arms to the sub-reflector using a flanged nut. Now, fix the 2 arms to the elevation head using another 4 shorter bolts. Lock off all arm bolts completely. The next stage is to fix the transceiver to the 2 arms. Slide the long posi drive bolts through the holes in the arms using the plastic spacers. Lock off all 4 transceiver bolts. Now, fix the parabol into place using the 5 small coach bolts and flange nuts. Locate all 5 nuts first and then lock off. To establish a connection with a satellite, it is necessary to point an antenna exactly at the satellite, which is stationed at approximately 36,000 kilometers away from the Earth in geostationary orbit. There are 3 parameters that allow you to start pointing your antenna to the satellite. Azimuth, the compass direction in relation to north, which corresponds to moving the antenna left or right on the mast. Elevation, the angle between the Earth and satellite position, which corresponds to tilting the antenna up and down on the mast. Finally, polarization, which is achieved by turning the ODU, or antenna, in relation to the satellite. These 3 parameters can be taken from your manual or from a number of websites and are calculated from your position on Earth in comparison to the geostationary position of the satellite. Now you have your 3 parameters for your line of sight, you can start choosing your installation position. You must have a clear line of sight to the satellite position with no obstacles such as buildings or trees. A person should be prevented from getting to within a distance equal to the diameter of the antenna. You should also have approximately a 10 degrees margin between your line of sight angle and any obstructions. The final criteria for choosing a good installation position is the maximum cable distance between the modem and antenna. The normal distance is 30 meters, but can be longer depending on the type of cable. When cabling the antenna, leave a service loop of about 70 centimeters to enable the replacement of connectors. At the point of entry to the building, put in a drip loop to stop water penetration. When drilling the hole in the exterior wall, please drill down at a slight angle to prevent water penetration. You should always drill from the interior. First, utilize the correct fixations for the wall, such as M8 raw bolts. You will need about a 1 meter diameter circle for the mast installation. Place the central bracket in the correct place and ensure it's exactly vertical, then secure with suitable fixations. Now, place the mast into the bracket and secure with 3 bolts. There are 2 short bolts and 1 long bolt for the center hole, all secured with flanged nuts. Now, slide the collar over the mast and attach the side arms with F1 on the right-hand side and F2 on the left-hand side. Attach the side arms with 1 long bolt through the collar. The side arms can now be attached to the wall again with M8 raw bolts. The mast must be absolutely vertical to ensure the antenna elevation scale functions correctly, and all bolts to be locked off. Normally, antennas are installed on a wall, but to allow us to film the pointing procedure, we fixed this antenna on the ground. Before you start pointing the antenna, you must preset your elevation, polarization, and finally the azimuth. Loosen the 4 elevation locking bolts on the head, then turn the elevation bolt until you attain the correct elevation value, which in our case is 33 degrees. To preset the polarization, make sure the 4 polarization bolts are loose enough to allow movement. Then spin the parabol to the value indicated, which in this case is 99 degrees. Now, lock off the 4 polarization bolts. To preset the azimuth, loosen the 3 collar bolts and turn in the direction indicated by your compass, which in this case is 167 degrees. For exterior connectors, always use compression connectors if possible. Strip away the inner and outer insulation to expose the center pin and dielectric. Make sure there's no connection between the shield and the center pin. Push on the compression connector so that the dielectric is flush with the bezel part of the connector. Cut the center pin about 3 mm above the connector. Ensure there's no earthing truss touching the center pin, then compress the connector. You must connect the TX of the modem with the TX of the transceiver, then power up the modem. Now connect the analyzer to the RX of the transceiver. Set the center frequency to the coverage you're looking for. Now you can begin to locate the satellite. Once you've found the position of the Hotbird satellite, you should optimize the signal. You do this by first adjusting the azimuth so that you pass the maximum signal point in both directions. This way, you find the maximum signal level and fix the azimuth in this position. Tighten the 3 collar bolts for the azimuth. Go to the fine adjust mechanism for the azimuth. Loosen the 3 bolts on the underside of the turntable, then slowly move the antenna left and right with a fine adjust to achieve the maximum signal level. Lock off the underside bolts to finish the azimuth adjustment. Now you move to maximizing the elevation by first loosening the elevation locking bolts on either side. Then adjust the antenna by passing the maximum signal level in both directions, up and down, to be sure of finding the best signal level. Lock off the two elevation locking bolts. Lock off with a spanner both RX and TX connectors to ensure waterproofing. If you're using different connectors, please tape up all connectors with self-amalgamating tape. Next, create a service loop to allow either connector replacement or even movement of antenna position. Use cable ties, normally black, which are protected against the sun. Connect your receive and transmit cables to the modem F connectors, then plug in the power connector. The RX LED will flash for a certain time while the modem searches for the signal. Once the modem has locked to the carrier, the RX LED stays on permanently. You should first verify that the end user's computer is correctly set up. Go to Start. Go to Control Panel. Go to Network Connection. Right-click on the local area connection. Go to Properties. Go to Internet Protocol TCP/IP. Click on Properties. Check that the PC is on IP address automatically. Go to the Control Panel. Click on Internet Options. Open the Connections tab. Check the PC is on Never Dial-Up Connection. Connect your PC at this point. Once the PC is connected to the modem, open your web browser. The screen should open onto the self-activation server. Enter your company ID and your activation code twice. Press Next. The modem will reboot. After the reboot, it will say Satellite Terminal is successfully rebooted. Once this process is finished, reopen your browser and you're connected to the internet.